In this video, we are going to explore the Intelligent Fixtures Line Dance fan effect. The idea for the fan effect was submitted by Vixen developer Nick Nelson. Nick is adding moving heads to his display and has contributed numerous ideas to help improve Vixen's support of intelligent fixtures. I want to thank Nick for developing the effect concept and for his numerous efforts testing the effect. The effect we are going to explore is named Line Dance. In the Effects pane, it is located with the other intelligent fixture effects. This effect is intended to target a group of moving head intelligent fixtures that are physically oriented in a line. Here we see the settings for the Line Dance effect. The first setting I want to highlight is the dance mode. The remainder of this video is going to be exploring the fan dance mode, but our intention over time is to add additional dance modes to this effect. The fan dance mode requires 2 or more moving heads that can pan greater than 360 degrees. For the fan mode to perform optimally, the range of the pan movement needs to be configured on the pan function. Let's demo this effect. The intention of the fan dance mode is to fan out the moving heads by an angle. The pan angle increases based on the position of the moving head from the center of the group. Everything that is being done with this effect could be done by multiple instances of the set position effect. The purpose of this effect is to make getting this fan movement easier and less time consuming. All moving heads in the group can be positioned with one fan effect. The line dance fan effect needs to be placed on a group of 2 or more moving heads. The moving heads need to be ordered in the group, either left to right or right to left. There are 3 fan modes that control how the fan is created. I will describe the 3 fan modes and then we will demonstrate each mode and talk about the settings applicable to the mode. The first is Synchronized. This is the default. All moving heads start and finish at the same time. The second mode is Staggered. Only 2 moving heads are moving at a time. The last is Concurrent. All moving heads start at the same time, but finish based on the amount of pan required. Most moving heads pan from their starting position in only one direction. This effect needs to pan some moving heads to the left and some to the right. To prepare for this, the effect initially pans all the moving heads 360 degrees. When you add the effect to the timeline, Vixen looks at the total range of pan movement and calculates a pan start value to pan the fixture 360 degrees. If we click the Advanced Overrides checkbox, we can see the pan start value. This value can be manually adjusted if your moving heads are oriented where a different pan start value is needed. To set up for the line dance fan effect, use the set position effect to pre-pan the fixtures 360 degrees and to get the desired tilt. This allows for precise timing for when to begin the fan effect and turn on the light beam. For convenience, a named curve can be created in the curve library and then drag and dropped onto the set position effect. Here I have created a 360 degree pan curve. You can see on the timeline, the first 2 seconds I use the set position effect to get the moving heads into position. Following that, I use 3 effects. First, I use the set position to continue to control the tilt. Note, I've deselected controlling the pan. Next, I use the set level effect to turn on the beam. Finally, I use the line dance effect to get the fan movement. In this next section, we're going to explore the synchronized fan mode. All the fan modes have a pan increment angle. This setting determines how much each moving head pans to create the fan. The angle that is selected for the effect is applied to the moving heads using the angle and the multiplier as shown. As you move from the center to the edges, the multiplier increases. Synchronized mode is the only mode that uses a curve for the pan increment angle. The curve gives you the most flexibility to create unique fan movements. On the pan increment curve, the 50 mark defines 0 degrees of movement. Moving the curve above this line will fan the moving heads in one direction. Moving the curve below this line will fan the moving heads in the opposite direction. To demo this, I'm going to have the moving heads increase their fan from 50 to 70. Here is what that looks like. Now I'm going to change the curve to pan in 50 to 30. This is what that looks like. Next, I'm going to configure the pan increment curve to fan in and then fan back out. The next setting to look at is the invert pan. To demo this setting, I have changed the pan increment curve to ramp from 50 to 70. With this curve, we again get the beams fanning out. Toggling the invert pan option will cause the beams to fan in, since it makes our positive curve negative. The invert pan setting is useful when your intelligent fixtures are mounted upside down or when you are applying large tilt values. The last setting to look at is the center handling. This setting only applies if you have an odd number of fixtures. The default behavior is the center moving head is centered as no pan is applied. The other options are to have the middle fixture pan left or right. You can see the middle beam is now fanning to the left. The next fan mode to look at is staggered. This is the stagger fan mode in action. You can see that the moving heads move in pairs, staggered over the duration of the effect. The stagger mode introduces a new setting that controls the fan direction. We just saw fan from center. Let's change the fan direction to fan from edges. Another difference with the staggered mode is the pan increment is a slider, but the setting still controls how far the beams fan out. The staggered mode introduces a hold time setting that allows us to control the percentage of the effect's duration that the expanded fan is shown. The default is 0. Let's change it to 20%. We can now see the effect hold the completed fan for a second at the end. The next fan mode to explore is concurrent. You can see with the concurrent mode, all the moving heads start to pan at the same time, but the inner moving heads finish first, and the outer moving heads finish last. The concurrent fan mode introduces one new setting, pan speed. The pan speed controls how fast the moving heads pan. Let's increase the pan speed and observe the results. We can see that the moving heads are panning out much faster in this demo. I thought I would end this video by showing how you can combine the line dance fan effect with set position tilt curve to get an interesting visual. We hope you find this new effect to be useful and a time saver. We look forward to adding new modes to it. Thank you for supporting Vixen.